Good morning, sir. Good morning, classmate. I'm Charles Dini Aquino from BS Ed Math 2B. So for today's video, we need to answer the item number 57 in chapter 2.4. So the question is, prove that A is n by n that is idempotent and invertible, then A is equal to identity of order n. But first, we need to define the elementary matrix. An n by n matrix is called elementary matrix if it can be obtained from the identity matrix of order n by a single elementary row operation. And remark, the identity matrix of order n is elementary by this definition because it can be obtained from itself by multiplying any one of its row by 1. So, we need to define also the idempotent. Idempotent, a square matrix A is idempotent if A squared is equal to A, or A idempotent of matrix A is equal to A. Next, we need to define invertible. Definition of the inverse matrix, an n by n matrix A is invertible or non-singular if there exists an n by n matrix B such that A multiplied by B is equal to B multiplied by A is equal to identity of order n. And we need to answer. We need to prove. First, A squared is equal to A because the idempotent of A is equal to A according to the definition. And next, we need to multiply the inverse of A, or A raised to negative 1, or inverse of A, because we need to prove that it is invertible. Multiply this equality by inverse of A. So we are all know that A squared is equal to A according to idempotent. So we need to change from A squared to A. And we all know that inverse of A multiplied by A is equal to identity, because in theorem 2.7, the uniqueness of an inverse matrix. If matrix A is invertible matrix, then its inverse, it's unique. The inverse of A is denoted by A raised to negative 1, because the inverse of A of an invertible matrix is unique. You can call it inverse of A and write A multiplied by inverse of A is equal to inverse of A multiplied by A is equal to identity. And lastly, we prove that A is equal to identity of order n. So it is correct, and according to all of the theorems and definition. That's all. Thank you for listening. God bless. Keep safe. Ciao, ciao.